All right, Chapter 1, Matter and Chains, Chemistry 101 here. Chapter 1 is basically a review of things that have been learned at Milton Union in 9th grade physical science. And so this video is going to compose these first 2 points here. We're going to review some basic vocabulary, and we're going to cover the classification of matter. Subsequent videos in this chapter will outline the other 4 particular goals, identifying properties and states of matter, distinguishing something called intensive versus extensive properties, distinguishing physical and chemical properties, physical and chemical changes, and learning the basic layout of the periodic table at the very end. All right, so chemistry, what we're going to study in here is what's called the composition. That's what it's made up of. The structure and properties of matter and the changes that it undergoes. So we're going to be learning in the next chapter some chemical mathematics, because mathematics plays a large role in what we do. Then we're going to talk about atoms and how they're put together, and we're going to talk about compounds and how they're put together, and we're going to talk about different types of chemical reactions, and we're going to be doing some chemical mathematics with this, and so lots of stuff that will eventually come to being throughout the rest of the year. Measure of the amount of matter is called mass, and you're familiar with mass. This is what we use the scales for. In our lab, we have the digital scales. Remember, there's a difference between mass and weight. Mass is the measure of the amount of stuff, sort of. There's some technicalities into this, as we'll learn in Chapter 3. But weight can be different because weight is the effect of mass in a particular gravitational field, meaning that if I have some stuff, that stuff has a mass on the Earth and it has a mass on the Moon that's exactly the same. But the weights are different because the gravity on Earth and the gravity on the Moon is different. So we can have different weights even though we have the same amount of masses. And usually what we're talking about for measuring matter is we're talking about the mass. Matter is anything with mass and takes up space, and you're familiar with the classic examples of solid, liquid, gas, and we're going to expand upon that in subsequent lectures. If matter has mass and takes up space, well, what's an example of something that does not have matter? And one of the classical examples of that is light. Light doesn't have a mass to it, although it does have momentum. There's some technicalities in that as well. But what we're looking at here is something with mass. Light does not have that, so light wouldn't necessarily quantify as matter. It's a form of energy, actually. Smallest unit of an element that maintains the properties of that element is called an atom. And here I have a basic sketch of what most people think of when they think about an atom. It's about the best humans can come up with. We have a nucleus at the center, and we got electrons whizzing about on the outside. Elements are pure substances that are made up of only one type of atom, whereas compounds are pure substances that are made up of 2 or more atoms that are chemically bonded together. So in this picture here, to the right, I have elements here on top. These are all diatomic elements. Hydrogen, oxygen, nitrogen, and chlorine. Diatomic meaning 2 atoms. So I have 2 atoms that are bonded together, but these are all elements because it's the same atom. It's hydrogen atoms, oxygen atoms, etc. On the bottom, I have 4 compounds. These compounds, this first one here is also diatomic. It's 1 nitrogen and 1 oxygen, but it's a diatomic compound. And I have 1 nitrogen, 1 oxygen forming it. And then the rest of these we all have, I guess you'd call them triatomic, where I would have 3 atoms bonded together. I got a hydrogen and oxygen compound, 2 different elements. 2 different elements, N and O. Again, look here, I got an NO and an NO2, same elements, different proportions. We'll talk about that later. Here's carbon dioxide, CO2, these are all compounds. And later on in the year, we'll talk about how these things bond and what's going on when they do and how the electrons are shared, and etc. Let's take a look at classification of matter. So up here at the top, we have all the stuff, all the matter. And we're going to ask a series of questions. And the first question you ask is, can you physically separate, can you physically separate this type of matter? And so matter is up here at the top. What does physically separate mean? Well, conceptually, let's just say you had a mixture of dimes and pennies. Well, I can sort the dimes and pennies out. I can take my hands and I can just sort them out. That's a piece of cake. That's a physical separation. What if I had salt dissolved in water? How do I physically separate the salt from the water? Well, you evaporate it. You evaporate the water off, and the salt's left behind. That's a physical separation. There's other ways to do that. What if I had, let's say, sand in water? How do you separate the sand from the water? Well, the sand doesn't dissolve, and so I can catch the sand in a filter, and the water would go through the filter. So that's physical separation. Different ways to do it. We're going to apply a bunch of different methods in the lab to do that. So, can it be physically separated? Answer, yeah, it can be physically separated. So we call those things mixtures. If it can't be physically separated, those are called pure substances. Let's take a look at the mixture side here. There's a couple of different ways we can describe mixtures. And what you do is you ask the question is the composition uniform? Well, what does the word uniform mean? If you think of uniform, you might think of the military, and they wear these uniforms. What is that doing? What's making all of the soldiers look the same? If you work at restaurants, there might be a uniform at a restaurant for you to wear. And the idea is to make people look the same. And so what we're asking is the composition the same? Can I tell the difference in the mixture? So in the examples I mentioned earlier with the pennies and the dimes, well, I can see the difference between the pennies and the dimes. That's obvious. So this is a composition that's not uniform. An example of the salt in the water, if I dissolve the salt in the water and I just look at it, I can't tell the difference just between pure water and salt water. I'd have to taste it or something like that. So salt water is an example of something that you have as a uniform substance. So that would be an example called homogeneous mixture. They're also known as solutions. I can't see the difference between the salt and the water. Sorry, salt and water. So here we have the salt water. On the other side, I have my pennies and my dimes. I can tell the difference. That's a heterogeneous mixture. Another example I give often is pepper water. If I take pepper and shake pepper into the water and stir it up, the pepper doesn't dissolve, and I can see the flecks of pepper all throughout the water. I can tell the water part from the pepper part. That's a heterogeneous mixture. Other examples of heterogeneous mixtures I give are blood and granite and milk. You'll see a picture of granite here in a minute. Blood and milk you may have problems with. You may say, well, if I look at blood, it looks kind of the same. I can't tell parts of it. And the general idea here is you can use simple tools to look at this, and one of the simple tools is a microscope. If you take a look at blood underneath a microscope, you can see the different cells in there. You can see the white blood cells and the red blood cells and the platelets and what have you. Milk is the same. I mean, what is milk? Well, milk is just basically the fat, the fatty part of the milk. That's why when you go to the grocery store and buy it, there's 1% milk and 2% milk. Well, the percentages are the amount of fat in it. And there's the sugar in the milk, which is called lactose, which some people are lactose intolerant because they don't produce the enzyme to break it down. So there's sugar in it. Now, you can't see the sugar. You can see the clumps of fat. And then you see the white stuff, which name escapes me on what that white stuff is called, but the white stuff is a protein that gives the milk its white color. And I can't remember if you can see that underneath the microscope or not, but maybe, possibly. And so you can see the different parts of the milk underneath a microscope. Milk itself goes through a process called homogenization to make the milk look uniform throughout. Without the homogenization process, you'll see that the milk looks watery and fatty and probably something you not necessarily want to drink. Over here on the pure substances side, pure substances, it's all the same type of stuff. And you ask, can it be chemically decomposed? And so can we do chemical reactions to extract the different elements out of that? And if it can be chemically decomposed, we have a compound because we can get the water and the oxygen from, we can get the hydrogen and oxygen separated from water. And so different compounds we had on the other slide, you saw CO2, H2O, NaCl, common ordinary table salt is another. If it can't be chemically decomposed, then you have your elements. And you're going to learn a bunch of different names and symbols for elements. We have carbon, hydrogen, potassium. All right, in review, mixture that looks the same throughout. So here's a picture of apple juice. Apple juice has a bunch of different stuff in it. You can taste it. There's sugars, colorings, different stuff like that from the apple. This is a homogeneous mixture or homogeneous mixture. Here I have a picture of graphite. This is a rock. I'm sorry, I said graphite, but I meant granite. Granite. Granite is a rock. It's made up of several different minerals. And if you look at this, I can see white, I can see black, I can see a lot of pink in here. These are different things that I can see. This is a heterogeneous mixture of granite, the rock. This ends this particular video. If you have any questions, please let me know. Thank you.